Okay. Yeah. So yesterday we stopped at like so we learned about exception, what is exception, and what are all the main keywords that we use when we have something in the exception, right? When you wanted to handle it. So we use try catch blocks, and what is finally block, we run that. And also we learned about throw keyword, whenever you wanted to return a user defined exception. Okay. So with that, actually, yeah, we are done with the exception, related things. Okay. And let us go and jump into a different topic, which is called like, collections. Okay. So what exactly is collections, right? So whenever you you whenever you wanted to store something, okay, some data, right? So have you ever think like, we still now we actually using a single variable, and in that variable actually we were, storing one by one value into it, right? So if you wanted to store the similar type of data, okay, into one uh in one place, okay, so how it can be possible, right? So if you wanted to store that similar kind of data, multiple data, okay, you can achieve this using collections. Okay, so let's see how. Yeah, so collections is like similar to an egg tray. Okay, so yeah, in the egg tray, right, it is storing all the eggs in a systematic way, right? And it will not it will not allow you to break them in the when you add it in the egg tray, right? So it has its own compartments, to store multiple eggs at the same time, right? So one tray for multiple eggs instead of having one for each, which sounds weird, right? Like, so that's what we are doing. Multiple eggs will have only one tray, okay? And we store all those eggs into one, right? So similarly, what we have in a class full of students, almost 40 of them. So, and we need to store their names in the computer using Java. So how do you do it? You definitely know how to do that now. So you are going to create 40 strings with the name 1, name 2, name 3, name 4, name 4, name 40 till name 40, right? So and start, storing the values for them. That's what, we thought of doing it. But it is like, it is okay. It is obvious solution for the problem. But is there, a better alternative? Yes. We had like the similar kind of, egg tray kind of thing. If we wanted to store everything into one, so how we do that, right? So we can achieve these things using an array. Okay, so it is called, that future name is called as an array. Okay, so let's see, how it is, how array looks and all those things, right? So array is a special form of storage. Okay, so which store multiple values, of the same type. Okay, so the values are stored in one after another. Okay, like a queue. Okay, or a stack. So, and we can access these values using an index, which will start from 0 to n. Okay. Yeah. So the first value you entered goes to the 0th position, and next to that first position, and so on, until unless if it is If you are having 30 students, it is going to be 29th position when we had the 30th one. Okay. So because it will start, the index will start from 0. So let's see, the various collections, whatever we have it. So we have lot of Java provided collections are there. Okay. And interfaces, collection classes, and also interfaces. Let's see, few of them. Okay. So array list, linked list, hash set, tree set, hash map. Okay. So we'll start with array list. Okay. Java array list classes, Java array list, like it is more like similar to the one whatever we just saw it, array. Okay. But the only difference that you will see it is, yeah, sorry. So Java array list class uses a dynamic array for storing the elements. It is like an array, but there is no size limit. Okay. So we can add or remove elements anytime. So it is much more flexible than the traditional array. Okay. So it is found in the java.util.package. Okay. So Java linked list uses a doubly linked list. Okay. To store the elements, and it provides a linked list data structure. So it inherits the abstract list class and implements list and DQ interfaces. Okay, so if you see, that is the example, whatever we have it, 10, 20, 30, and you see it is there in the linked list format. So yeah, we'll see an example of both array list and linked list. Okay. Yeah, before that, just there are few differences when we compare with array list and linked list. Okay. Array list, it internally uses a dynamic array. Okay. And, to store the elements. Linked list internally uses a doubly linked list to store the elements. Okay. So manipulation with array list is slow because it internally uses an array. And if an element is removed from the array, all the other elements are shifted in memory. Okay. So manipulation with linked list is very easy because, faster. Okay. Because, it internally uses doubly linked list. Okay. So there is no bit shifting is required in the memory. Okay. So it is just only changing the uh, next memory, value with before in one of the storage. Okay. So an array list class can act as a list only because it implements lists only. Okay. But linked list class can act as a list and queue both because it implements list and DQ. Okay. Interfaces. Okay, array list is better for sorting and accessing the data, and linked list is better for manipulating the data. Okay, so the memory location for elements of an array list is contiguous. Okay, the location for the elements for a linked list is not contiguous. Okay, so generally when an array list initialized, a default capacity will be 10, and there is no case of default capacity with the linked list. Okay, so in linked list, an empty list is created when a linked list is initialized. So to be precise, the array list is resizable array. So linked list implements the doubly linked list to the list interface. Okay, those are the very common bit differences between array list and linked list. Okay, let's see a couple of program, okay, with array list and linked list. Okay, so just a minute. Okay, so if you see here, uh, I already have an example with array list. Okay, so just a minute. Just a minute. Yeah. Okay. Okay. So the example is, it is for array list example. Okay. So what I'm trying to do here, so I picked up, I just initialized an array list. Okay. So I have given this, because I wanted to store a string object in the array list. Okay. So array list, is equals to new array list of string object. Okay. So this is how, I'm creating an array list, and then using dot add method, you can add elements into that list. Okay. So what I'm trying to do, list dot add, I'm just adding all these values. Okay. And I was just printing system.out.println list. Okay. So let's see what it is going to print, right? And when I use something returning element, so list dot, when we are when we wanted to add something into there, you are using add method, and when you wanted to get something from there, you have to use dot get method, and the position of that element, okay, which position you wanted to get it, like 0 position, 1 position, 2 position. So depending on that, you can just add that element position. So here I have just added one, and when it comes to the arrays, like the one is the second position, because it starts with the 0 position, right? So yeah, get of one will give you the second position, second element, that is apple. Okay, on the screen. Okay, so what I'm trying to do here now, I'm trying to change the element which is positioned at the one, right? So for that, actually what I'm trying to do, I'm using set method instead of add method. Okay, so what sets that? So set is going to take two parameters in it. The first one is the position of that element, and what it needs to be changed. So if you give like 1 comma watermelon, so it is going to override that apple, and at the one position, actually watermelon will be there. Okay, so, and yeah, so if you remember, there was a for each loop which I was talking about, when we had this loop related discussions. So for each loop was used in, mostly used in, in case of our collections. Okay. So what I've done, actually, for each loop, you create a variable which is called string fruit. Okay. Why I created a string fruit? Okay. So when you wanted to iterate and list, or any collection, okay, so you have to know which kind of object that list is storing, right? So in our case, actually, this list is storing string objects, right? So for the first, so what you need to do, you can, get that position um, string. So you create a string variable, and this colon, and then the iterable list, like which collection, uh, what wherever we stored something, right? That collection should be here. So if it matches with that string object, then you will get each string object into the fruit, and you can utilize that fruit, to print it or to modify it or something else. Whatever you wanted to do, you can do that. Okay, so let's run this example and see how it is going to execute. Okay, Java RList example one. Okay, see. So initially it printed the entire list: mango, apple, banana, grapes, and then we are looking for the first position, sorry, second position. So we just added that you know something dot get of one. So it returned apple. And what happened actually after apple? I tried to replace that position with watermelon. It replaced with watermelon, and it printed here. And the next level, actually using for loop, you are trying to print mango, watermelon, banana, and grapes. Yeah, yeah. Depending on your requirement, whenever you are writing some program, collection, code, something else. Yeah. So depending on your, like, the functionality of your code, or depending on your data, you know, uh, we choose a proper collection, okay, in the program. So if it is only dealing with sorting, and if it is dealing with similar type of elements like that you wanted to store, the array list is the mostly used frequent one for all the programmers. And in case of, like, any key related pairs and all, the mostly used hash map will be the one which is mostly used, whenever you have a kind of key and value pair. Okay, so let's go and check with the linker list one. Okay, so what is linker list? And in the linker list, actually, I have used a similar concept of program. Okay, it doesn't have any extra changes, but yeah. So how do we add it, and how do we print it? Those things a little bit change because of we use link, right? To queue, right? So I have a linker list one, and I just created a linker list with same string object internally what we are going to store. So what we have done, we added four strings into that AL, the linker list. And now what we're trying to do, we are trying to get the iterator. And this is one way that you can print all the values of your program using iterator. So iterator is also an interface. Okay. So what it does, actually, it is going to iterate the entire collection when you use that AL dot iterator, and it is going to throw, sorry, it is going to, uh, yeah, it is going to return that string object. Okay, and for every string object, actually it is going to uh, it is going to check that whether the next position is having object or not, like the expected object. Okay, for every iteration, that is, our has next will check it. What has next check? Whether this iterator, whether this string, sorry, whether this this object is having the next element or not. So it is going to check that, and if it is having, it will proceed to the condition, to print something or to perform something. If it is not there, then it is going to stop here the execution of this loop. Okay, it will come out. So here what we are trying to do, we are just adding al dot add 1 comma emi, right? And we are just trying to print the same thing. Okay, so here also again what we have done, uh, yeah. Okay, so in the iterator, actually, I just used al dot iterator over here. But if you see here, there is one more method that I have used, which is descending iterator. Okay, so the what it does, right? It is going to return the similar kind of iterator over the elements in this DQ. And what it does, actually, it is going to reversely sort them, reversely, uh, we can sequence them, and it will be printed very fast. Okay, this is all happening because of it internally use that queues and d-link, right? Linker list, right? So let us run this program, and you see how that it getting sorted using that descending iterator. Okay, okay, so if you see here, first it printed Ravi, Vijay, Ravi, Ajay, right? And after this invoking position based add value, so it is like it printed Ravi, Amy, Vijay, and Ravi and Ajay. So Amy was the one, I think, which we added. Then, you know, uh, Amy only, right? One second, let me check back the code. Yeah, we added Amy, and then we just printed AL after invoking the position based value. And we just, then we added the descending iterator. So Ravi, Amy, and Ravi, and Ajay. One second. So what was the console that what we are looking here? Okay. So what it done, actually, after this, it tried to uh, print it in the descending order. What was the descending order? From the reverse way, like Ajay, Ravi, and Vijay, and Amy, and Ravi. Okay. So that was the descending iterator, whatever we called it. Okay. So in the normal iterator, actually it printed from the first position to last, and in the descending iterator it is going to print the values from the last position to first, like Ajay to Ravi. So it printed Ajay to Ravi. Okay, so that is where that we have those descending iterator and normal iterator to print all these collection related values. Okay, so these are the two examples, and tomorrow I'm going to cover there are multiple examples with hash map and hash set, and also, and I'm going to cover like comparator and comparable, how you can write your own method to sort something, or to uh, those examples I'm going to cover tomorrow. Okay, but I'll cover a couple of things today about the hash map and hash set, and then we can wind up. Okay, just a minute. Okay, so when you're building those apps, right, or whenever you wanted to write some programs, okay, so for which kind of data, so which collection you need to take it, right? So we need to understand that kind of data types where we need to use it, okay? So then you can easily develop the applications using those collections, right? So on which condition you go with hash set, right? So Java hash set fits great when you don't want to have duplicate objects in your collection. So mostly, like, the people will go with set whenever they don't wanted to see any duplicates in the data. Okay, so on which conditions, like, you go with the asset, whenever we don't require the duplicates, okay, duplicate data. Okay, so in the hash map, okay, so a data which requires a key and value pair. Okay, so whenever a data something like requires a key and a value, so in that time, people generally go with hash map. Okay, so let's say if you have a dictionary, okay, so where each word has its own definition. Also, we need to get insert and remove words from a dictionary quickly, right? So hash table or hash map makes sense because you take the keys, words will be the keys in the hash table, and there are supposed to be unique definitions. On the other hand, will be the values. Okay, so that's how we separate them. Okay, the keys and value. Okay, so in that condition, we are going to use. Okay, we are going to use hash map. Okay, so when we go with tree map, right? So a tree map relies on a key value pair that cannot contain null values or duplicate entries. Okay, but the hash map can have null values and also duplicate entries, because but the key is not a duplicate, but the value can be a duplicate in the hash map. Okay, but in tree map, actually it cannot contain null values and also duplicate entries. So it is sorted in a natural order by key, or in a custom order by another custom comparator that we can also build it. Okay, so if you want to visualize this part to old relationship among all, a large number of categories, yes, yeah, we have to go with tree map. Okay, so I'll give you these examples tomorrow. Okay, hash set and hash map and tree map. Okay, how we can add those elements, and how we can display those elements using tree map and hash map and also hash set. Okay, so in that, actually I'm going to cover one more extra, like comparable and comparator. Okay, uh, related things. But for now, I will continue with the class with the threads, the next topic, and we'll shift the collections, whatever the three collections, whatever we discussed, right? I'm going to show you those examples tomorrow. And if you need more details to more things to cover in collections, I'll do that. Okay, in tomorrow's class. Okay, with those examples. Yeah. So so just a second, one second. Yeah. Okay. So, do you guys are okay, to cover those collections tomorrow, or if you want me to cover these topics after discussing those collection examples, I'm still okay, to cover them after it. Okay. If you are okay to continue the next topic now, and tomorrow if I cover those examples, is this okay for you all, guys? like or you wanted to stop it here, and then tomorrow we continue the collections examples, and then we go for the next topic. So what do you say? Can I continue now with the other topic, or do you want to stop here? Okay. So guys, other. Okay. So I'm saying continue, for the other topic, so that I can cover tomorrow. Okay, yeah. So I'll continue with the threads now. Okay, so I'm gonna cover only the theoretical part with threads, and I have a couple of programs that we can discuss for threads as well. We'll do that. Okay. Okay. So threads and parallel processing using multi-cores and functional programming introduction. Okay. So this is fine. Just ignore these two. Okay. So what exactly the threads, right? So threads, like in Java, now we do have lot of options. Uh, not to go with threads. Okay, there are a lot of other ways that we can still run these. This kind of schedulers or whatever we wanted to do it. Actually, we do have lot of options, but now, but the threads were the one which was introduced by Java. Okay, so where and when we can use this thread in real time, right? So we have a two-step process in a mail service call. Okay, so you're calling a bank service, okay, to get your statement now and send a mail copy to your home. Okay, so what happens, right? Whenever the first step, okay, so one needed, step one, need to return your statement immediately back to back to you as a response. Okay, so what you have done, you just called Bank of America, some of the customer care of the bank, and you are looking for your statement. Okay, in the IVR, like whatever the call that you have done, right? You call them, so you selected one of the option, okay, to get the immediate view statement for you, okay, and later you are requesting a home delivery with the statement, okay. So what it does, step one, it is like, need to return your statement immediately back to you as a response. And the step two, need to create a sync process, okay, which should run on its own and perform the request to complete a mail copy request for the customer. Okay, so what we'll do, actually, for the step one, it is like a sync, that is a synchronization sync process, like it should be done immediately. And the step two, actually it can be done later. So what you are going to do, you are going to store it somewhere, saying that this customer requested, this request, to send it to home, something like that. You store it somewhere, or you can create an asynchronous process using threads. Okay, so we can achieve that asynchronous process using thread, and this thread is responsible to either generate that file or deliver that file. It is going to perform that action. Okay, so this asynchronous process, whatever you are trying to do it, right, it is called the thread. Okay, so which we can achieve in two ways. Okay, like how do you create those two ways, right? How do you create those thread in two ways, right? So one is using a thread class, okay, and the other one is we can use runnable. Okay, so let us check how an example of the thread, how it is running and all. Okay, we'll check an example once again. Okay, yeah. So guys, if you see here, so I have written this thread example, okay, so which implements thread, okay. So just, whenever you wanted to implement something in threads, there are two things that you have to remember. One is start method and the other one is run method, okay. So when you call that start method, okay, thread is not going to execute the start method. Instead of start, it is going to execute run method asynchronously. Okay. So how it does, we are going to see it, okay, just now. So what I've taken actually in the thread example, I have just implemented run method because I'm just extending this thread. So thread will be having thread classes having, run method and start. Okay. So I'm implementing run method. What I've done actually, you know, initially I was just asking that thread to sleep for, 100 milliseconds. Okay. So, so that's why, I just added try thread dot sleep. So sleep is the method, okay, which helps us, to sleep the current running process for 100 milliseconds. Okay, so it is going to stop the execution in between. Okay, so where we use this kind of sleep, right? Okay, so there are multiple places that, the sleep can help us. Okay, so one of the best best practice is like whenever you are trying to connect a database in the threads, or whenever you are trying to connect some FTP file transfer protocols and FTP servers. Okay, so between one connection to but between one transaction to another transaction, so we just allow that thread to sleep for 100 milliseconds and then we start the next transaction to be processed. So one by one. Okay, so in that case actually, we use this thread dot sleep. Okay, whenever you are writing some, big programs and all, so the thread dot sleep is mandatory. Okay, yeah, and also if you like, if you are processing something in the background, like, there are multiple files that you need to push it to some other location, whenever the folder is empty, actually it is going to check that folder, and so it is going to be like, if the folder is empty, then you wanted to stop that thread for some time, right? So in that cases also, like, you use sleep methods for the thread. Okay, so let us come to the next point. Okay, so what I'm trying to do, I'm giving a while of true. That means this is the infinite loop that I'm creating. What I'm creating? So I'm creating an infinite loop of thread. Okay. So system.out.println, I'm just giving that thread started running and just declare a couple of variables and printed them, and that's it. So this is going to be, this is going to run forever, right? Because it is while true, right? So let's see now what I'm doing here. I'm just, I'm just giving thread, creating an object of that thread example one. And instead of calling t dot run, what I have called t dot start. So calling the start method, to execute the run method of the thread class. So which will be done by asynchronously. Okay. So what I've done actually, after that, I asked actually thread.sleep for 1,000 seconds, sorry, 1,000 milliseconds, and then I just printed a couple of things. So I just wanted to show you how these things are going to work. Okay, so let me run this. Okay, and I'll show you how the thread is running. Oh, sorry, one second. One second, actually it got stuck. Okay. See, yeah, see, it is still running. Okay, so I don't want to increase that CPU load and all. Okay, I'm just stopping it here. See, so what did happen? Actually, it started continuously running that, right? So because it is there in the loop, right? Okay, so let me go back. Okay, in the thread example. So this part is always running, right? Thread started running, and this one. Okay, so let me put multiple dots here, and then it is printing sum of two numbers in the result, right? So once this is done, actually, it continuously falls in this loop. Okay, so let me do something. Okay, so if p result equals to 22, then yeah, let me save it and just run this one. Okay, so instead of 100, what we can do, Java thread example one. See, it was printing like very fast earlier. Now it is taking some time, to print that, right? So let me break this one also. I'll show you it very, okay, one second. Uh, Instead of 1,000, I'll just add it as 500, and now just run it. Okay, Java thread example one. See, it is just waiting for that 500 milliseconds, and it is keep on running that thread process again and again until unless we stop the container or we stop the server. This thread will be keep on running. So where do we use these threads? Like, as I mentioned, if you wanted to like something that you wanted to do it asynchronous with the regular process, okay, and you wanted to, like, stop, sorry, you wanted to send something to customer, okay, without impacting the regular process of your program or the project. So you use these threads, okay, which can help you to perform all the asynchronous processes, okay. So like I already told couple of examples. One is like, if you wanted to transfer some files from some of the server to a different server, okay, and depending on some conditions, you can do those things, in a thread process, okay, to transfer them. And the other one I already told, like, whenever you requested for a statement, to customer, so you immediately you can trigger this, and you can get all those details of the customer, and then you can send a mail copy to them. This can be happen in the background using these threads, okay. One second, yeah, let me go back to the back. So first one, actually, we just saw one way of creating those threads, like, the one which we just saw it, that is thread. Using thread class, actually, we are trying to create those threads, right? And the second way, it is runnable class. So I did not added any example for that, but it is pretty much same like whatever we are doing it now. So you can utilize that runnable, and and you can just implement the thread, okay. So you can get various multiple examples in Google, okay, using runnable, okay. You can just verify that it is pretty much similar whatever we have done it with the thread. Okay, let me go to the next topic, okay. So the parallel processing and functional programming. So actually, Java, introduced very good concepts in Java 8, okay, using kind of parallel processing, and streams, and different kind of functional programming concepts, okay. So Lambda expressions and all, right? So what exactly this parallel processing? So how you can use them, right? Okay. Parallel processing, right? Whenever you see a computer, right, or a laptop, okay. So which always say that it has multiple cores, and it has multiple you know processors, like that you can run your computer very fast using those processors and all those things, right? So how do you utilize them in your program, right? So if you have multiple cores, you're running a 8-core laptop, okay. So how do you utilize them in your program to make it more faster than compared to the regular programming style, whatever we do it, right? So for those things, actually, we do have this parallel processing, okay, and you can utilize multiple cores of your application, sorry, your computer, and you can increase the fastest, you can increase the, what do you say, the processing time of your program. Sorry, you can decrease, sorry, okay, you can decrease the processing time of your program using multiple cores, okay. So that means it will be very fast when you are executing a normal program, or when you are executing this parallel processing, okay, uh, program, okay. So I'm gonna give you those examples tomorrow. But yeah, for now, and actually, what exactly the parallel processing will learn it. Okay. Okay. So the example will be on the parallel processing. I'm going to use int stream and parallel method. Okay. So how these methods are going to help to run the program very quickly. I'll show you those things. Okay. So far Java is supporting the imperative style of programming and object oriented style of programming. So the next big thing, like Java is stepping into the functional side. Okay. So has been added more related to that functional related style programming. Actually, it is keep on adding its own it keep on adding more features which are uh, capable enough to convert to a functional programming. So one of that is, okay, higher order functions in functional programming. So in functional programming, actually what we are doing till now, we were learned about like object oriented programming, right? So Java is shifting more to the functional oriented programming. So that means instead of going everything with an objects, I think we are giving very higher specific thing to a function. Okay. And in the higher order functions, okay, the functional programming functions are to be considered as a first class citizens. Okay. So that is, so we are going to stop using object oriented programming. Instead we go with functional programming. Okay. So we can pass objects to a function, we can create objects within function, we can return objects from a function, and lot of new ways that speed up your code. So that means, you don't require to create a separate class and, use that class to create an object and, utilize that object, to call some methods in the class. So all these steps actually, going to be reduced when you go with the functional programming. So inside a function, you can create a, kind of an object, inside a class, inside a function you can create a new class which can return something, some values and all. So these things can happen in the functional programming. Okay. So yeah, we are going to discuss that with the example. Okay. With lambda expression and all. Okay. So how we are going to achieve the functional program. Okay. Programming in Java side. Okay. And one more example that we are going to see tomorrow. So in Java, we'll take one example. Okay. One example how the Java added features, to decrease your programming steps. Okay. Let's say, if you wanted to build a program for one of the logic, you might take 20 lines of code you have to write in one time, like when we are using 1.5, 1.6 of Java. And when you use that 1.7 and 1.8, how much lines of code that it got decreased. And when you use Java 1.11, how much lines of code it got decreased. And when you use 117, okay, Java 17 or something, how much lines it got reduced. So those kind of revolutionary changes what happened when you develop a Java program. So we are going to check one more example with that. Okay. With a different type of styles, like how you can reduce your programming code. Okay. Using the latest Java versions. Okay. So that is also one example that we are going to discuss tomorrow. So the first one is we are going to take hash map and hash set, and also the tree map or tree set. Okay. So that example that we are going to see first, within the collections. And if you guys wanted me to cover something else on the collection, I can do that. Okay. With a program. And other than this, we are going to cover parallel processing. Okay. With the in stream and parallel method. And also one example with the functional programming. And the other one is we are going to cover the revolutionary changes of Java, which helps us, to reduce our code while writing. Okay. With for a different, for one kind of logic. Okay. I'm going to take one example and I'll show you. So do you need anything to cover on the collection perspective? Very specific, like, you wanted to see what exactly this collection is, and where to use and all those things, let me know. I'll try to cover that one as well, tomorrow. So what I'm gonna cover, I think you already know about collection. So if you wanted to cover extra thing, let me know. I'll just add that one, okay, for the tomorrow's class. Okay. So I'm not getting any response, so I'll just I'm gonna cover them whatever I have added in my PPT. Okay. So if you need anything, yeah, let me know. Okay. So guys, I'm just
Excuse me, sir.
sharing. Yeah.
As you said that you will share that PPT
Yeah,
with
I'm sharing it
examples.
now.
Okay.
I'm sharing it now. Okay.
Okay.
I was just about to share that. Okay. So in the chat, I'm just sharing it. Okay. So you can download it from there. Yeah. Done. Okay. So tomorrow I'll share the next one. Once we completed this one, I'll share the next one, next topic related things and all. Okay. For now, this is the one. Okay. I just shared only with one guy. I'm sorry. Okay. One second. Huh. Let me do that everywhere. Okay. Yeah. I'm just sharing with everyone. Can you confirm, Randeep? Randeep Kaur, right? You're asking
Oh,
that.
yes, sir. I got it.
Oh, okay. Yeah. Thanks.
Thank you. Thank you.
Sure. Okay then. So tomorrow we're going to cover those topics, and okay. So yeah, if you have any questions on today's class, do let me know. I can reiterate them, or else we are good to go. Okay. So if you don't have any questions, yeah, yeah, we can wind off now. Thanks. Thanks all. Have a good evening. Bye.